All right, appreciate the opportunity. Appreciate that both Chris, introduced me to give this speech, and I would like to present what is my most recent practice in Chevron, and also share my view and how to improve the oil gas process industry digital transformation process, and with some rethinking or new thinking, and challenge you guys, think about the new platform, new technology to help the industry. Okay, so I have an agenda listed here, and mainly I'm going to talk about the 5 cases and give you the idea what is the current platform we use, pretty much not just the Chevron, pretty much all the industry. That's how they utilize the system right now for the online monitoring. Okay. Then I'm going to talk about my view about how we should move forward and how we're going to think about the future, maybe after 10, 20 years, autonomous operation. Okay. So before we started, and I have to present my view of the digital twin. So the digital twin, the word has been used for a long time, maybe 10, 15 years. Every business sectors or functional silos has its own definition of the digital twin. And in my mind, and the digital twin should not just be the physical asset, because currently most of people refer to digital twin, they just think about the physical asset. And in my view, the digital twin, not just me, myself, but anyone to dealing with the operation and the process and the fluids, and the digital twin should also including the productions, process, system, and should be including the fluid properties, conditions, and all the engineering attributes. And the component should also involve in the future. You can call the digital twin, but the more broad is real-time data and any static data. And right now, a lot of robotics, people think about the robotics, how to use for the process oil gas industry. And they should include the virtual sensor applications, any models, including the machine learning AI model. But currently, most of the models is rigorous models. And then IoT, 5G platform, all right, and to help the digital transformation for current facility. Okay, so those are the my view of the digital twin. Okay, so I listed here not just the 3D models, because when I talk to most of the company, they just think about 3D models. Okay, it's not completed. And the virtual sensor, virtual sensor also the term used to being is being used for or mentioned for many years. Really, the virtual sensor in our practice is a software. Okay, is including the product, the properties, process conditions, and allowed us to build a large models to cover the large field applications. And later on, I will mention that. And it is a rigorous model based currently, and I will later on to telling you, and I hope for the future, and should move to the more machine learning AI related application rather than just based on the rigorous modeling. And I will talk about the pro and the con later on. So this is a kind of different the view than traditional virtual sensor. People just think about one sensor and in one particular location for the calculations. Is not. It is more comprehensive, including not just the engineering parameters, and also a lot of the cross-functional parameters related applications I will discuss later. And the robotics applications, that area, I really believe the new technology can be play an important role. Really, the robotics application in our industry is not advanced at all. Basically, not a whole lot of application at all. There's some limitations in the past because company never pay attention. And now they pay attention mainly is in the inspection area. And also robotics itself, and you have to satisfy the production environment. They call the zone 0, zone 1 environment to protect the operation safety, all right? To avoid the explosion or something, fire, those kind of conditions. But the current practice, robotics for the isolated applications, either in the deep water tanker farm, and there's a few applications, but those are in the zone 1 environment, but don't have the zone 0 yet. Okay, so I think this area should, in the future, should be whoever developed the technology should pay more attention to this area because this is really useful. And another is the Internet of the Thing. You know, people talk about Internet of the Thing, 5G, and the network. Really don't currently, it doesn't matter which company, it doesn't matter those service companies, Siemens, Honeywell, whatever, you know, Yokogawa. They don't have the clear view and how to build this IIoT. And I read a lot of proposals, but most of them, they still think about improve the current PCN network within PCN network or within the corporate IT network. In my view, my practice, and I really hope the young generation should really think about new ways to design the oil gas facility IIoT and not too much interfere with PCN and the corporate IT. And I will describe later on, okay? So obviously people talk about that, you know, everyone moved to the digital transformation, want the more data analytics. So digital twin solution played an important role. The benefit because I always support operation, so my view is more close to the production operation, that angle, okay? Really, the digital twin solution can benefit a lot of things, particularly can integrate all the existing information together, production information, process conditions, chemical information, and the equipment, the machine learning conditions. Because all those conditions belong to each functional silos. That's what it is right now. And based on the job descriptions, and the people always focus on their own silo. And but the production is a real world, is a chain. And they don't know, in the real world, there's no silo. They're always connected. So it's just a human being knowledge. So when they learn the background to separate those, the information become the silos. The come down the real operation is really bring the inconvenience, inefficiency. And with building this integrated system, and allow the engineers, operators can identify inconsistent information and to quickly and identify the opportunity quickly to benefit the production, okay, and operation, and for safe operation objective or for the reduced LPO. The LPO means the loss of production windows, okay, those kind of opportunities. And another thing is the most important is with this integrated platform allowed us to analyze a lot of things used that we cannot analyze because we don't have that platform. for instance, it is an engineering index, okay, like for instance, like erosion, FIV. FIV means is the fluid-induced vibration, and those behaviors, and we can quantify those behaviors and become the index and to guide the operation. And another thing is like a material aging index, corrosion index, and also can allow us to build a more comprehensive integrated operation window and the condition regime map to guide the operations. So the operation, what we talk about it here, it is more complicated. It's not that if we just think about the refinery process is more steady state, but for upstream is more dynamic. You have the reservoir conditions, you have the well flow line and riser and the topside separation process. Then you have the gas, water, water treatment. They all have the different objective, and we put them together. And who has the priority, and who have the problem the most of the time you need to deal with, all right? And put them all together, and then you can identify, then you can maximize the production, which is, let's say, the crew, okay? And also to quantify the operation boundaries for safe operation. So without those kind of system, it is really difficult to do the operating management, okay? That's my point of view. So this is what I said, that we need to build the operation advisory platform, okay? It's kind of duplicate key business driver. I go quickly. You all understand that the optimized operation efficiency, workflow, and the feasibility study, and systematic integrate and reduce the risk, okay? And the remote operation support and monitoring. This is really useful, particularly for the COVID-19 for the last year before I retired. And our system allowed the operators and the coordinators and engineers, they can work in the Houston, at home, United States, to monitor the facility in the Nigeria and the Angola, okay? Robotics unmanned facility, and people are in our industry, oil and gas industry, they already talk about this probably 5 years now, and I don't see any significant move. Okay, people understand in the future this is really important, but right now the two challenge. One is the knowledge, technology may not be ready, and another is the people mind, the behavior, operation behavior is not there also, and most important is investment is not there. Okay. Improve the production and reduce the footprint. This is very important for the offshore or any larger plant. And we always want to increase the production, optimize the production, reduce the footprint in the facility, because it is really zone 1 unsafe operation environment. And we always want to optimize the workflow, but this is the business driver to improve, to adopt the new technology to improve our facility. Okay, so if you guys have a question, just stop me anytime. Okay, so once I talk, I just talk. Okay, so the background. I would like to talk about a little bit of the current practice and what I see the challenge, okay? Currently, the facility design, first of all, by the time the facility design, no one think about the digital twin, or no one think about the digital transformation, that kind of technology would be applied, all right? So most of the facility is designed without without those support platform. And most of facility or field is brownfield. And in order to apply those industrial Internet of Things or digital transformation, really, as the owner side, they always feel very difficult because they don't have enough of a budget to achieve that goal. In addition, and most people with the traditional mindset, they always think about improve the PCN network or corporate network. Next slides I will show you. Okay, so let me describe a little bit first. So, and also all the solution application, even I designed, later on you're going to see all the solution is really based on almost 20 years old client server technology, which is really old, all right? And now you have like edge computing, cloud, all those kind of application is not applied in our industry yet. And mainly is in the corporate IT level, not really come down to OT. They call it OT, the operational technology level. Another is the current model, any model. Chris knows that he works in the big field. Most of the solution is based on the rigorous software. Okay, we have a rigorous software for our industry for 40 years. Okay, and come down to today is very matured, but most of the people, including myself, and think about utilize existing model, rigorous model, and which is not designed for online solution, drag to the real-time online solution environment. Really, and increase a lot of cost and difficult to maintain and difficult to integrate as the more robust, reliable solution. So that is the reason we want more machine learning and AI type of digital analytic solutions in place. And I don't believe we are in that faster trend yet. Just people just start to think about how to use it, right? This is also, that's what I say, you know. Another thing is the oil price right now is dropped significantly since 2015. We're facing the challenge to have enough budget for the research and for the project implementation to adopt the first century high-tech solution, right? We have the Microsoft to help us, but it's really, really slow and through the normal project cycle, okay? Robotics is just in the test, don't have the comprehensive vision yet, and really is opportunity for the high-tech companies to think about whoever, you know, the young generation think about that is area. I think you can see significant improvement. Deep learning, machine learning, AI technology talked a lot last, I would say 3 years. People plan for some applications, but really don't have a whole lot of application in the real world. Okay, so that is the challenge. And also current workforce, I don't think they understand any deep learning, machine learning, AI good as you are, okay? And that is another challenge. So this is to give you the highlights of the what is mentioned, the network, okay? So basically, in our facility, it doesn't matter oil gas facility, refinery, chemical plant, basically they are same. The level 0 is a unit operation equipment, okay? And the level 1 is instrument, some is PLC, okay, sensors. And the level 2 is a DCS, SCADA system control. And the level 3 is advanced application and the client server network, what we call it. And the level 3.5 is a DMZ zone, okay? It is for advanced applications. So in the past, a lot of application solution application is in the either 3 or 3.5 level. Last 5 years, they moved to the business network. And the reason is the database is more mature and allowed us to pull the data to the database. And also cybersecurity network technology improved significantly, and people more comfortable to put all those solutions in the business network and can be protected from a public network. Okay. And currently, all those solutions, there's many, many solutions. I just use some examples. All those solutions existed. It is either in this level or business level. I would say before 5 years, I would say maybe go back to 5 to 15 years, they probably live in this level, okay? The client server network, which is within the PCN network. And I would say started from 2014, 2015, and most application designed and people put in the business level, okay? And but they all as a silo for function, they silo. They never connected each other and don't have the digital transformation view, digital twin views, or IIoT views. And it's just served for limited objectives. Okay, that is the current status. So from now on, I would like to talk about the 5 cases, the different area, give you the idea what is current practice level and the technology adopt. And then I talk about my vision and how to move from this kind of status to new status, which within short time, I would say maybe within 3 years can be achieved, okay? That's my view. So all those 5 cases, even as today, since I left Chevron and I studied some other companies' information and considering the digital transformation roadmap and look back what I leaded those projects and based on my vision, and I look at, and those technologies still old technology, okay? So I go one by one. So this is the Agbami FPSO. IOC means Integrated Operation Center, Backbone Support Solution. That's actually has 5 different application solutions, but I just lump some together because of timing, okay? So Agbami is one of the flagship of the Chevron asset, okay? It's been in production since 2008. And my involvement is since the phase 3, almost end of phase 3, which is front-end engineering design. Then phase 4 is a detailed design, construction, and the phase 5 is the operation, which started from 2008. And I was lead engineer responsible all the simulations, including the marine side also, okay? So all those solutions really is a production rate optimization and to reduce the LPO, the lost of the product window, okay? Because we have a lease, within this lease, we want to produce more as possible, all right? And for the corporate interest. And the integrated planning for both subsea and the topside. So in the past, the technology cannot be integrated with subsea simulation because transient simulation, topside is traditional process simulation together. And I would say I'm the pioneer person to put them together. And Chevron in this, we basically developed we put them together and simulate at the same time steps, much better way. I would say Chevron probably is the leading company in this area, is better than the Shell and ExxonMobil. Okay. We solved so many problems. I just highlighted here, okay, over the 10, almost 12 years, all right, 12, maybe 13 years period. The first, the educated operator and the educated engineer, and how to reduce the LPO, because there's so many the trips, and how to manage the trips to avoid the unnecessary shutdown. And another is the how to optimize and stabilize the RVP. And RVP is the read vapor pressure, is one of the index is for the crew quality. Okay, and that is a real-time they monitored, and there's no measurement. If you send to lab, it's too late, so we use a simulator, okay, to monitor. And control optimization, because it's dynamic. Sometimes you have more gas, sometimes more water. And for Agbami, mainly is the oil and the gas, and also compressor fail, the pump fail, is planned. You know, you always have this problem, that problem, and how you're going to manage the control to avoid the local upset, but still maintain the production. All right. So, and also the safety management, and how you're going to manage the high GOR in the later days, and over the time they have the high GOR and the sand issues, so on and so forth. So all those is because there's so many job functions, they work together. If you don't have the solution platform, and you can call it digital twin platform, whatever, and all the disciplines that argue each other, they cannot make the operation production plan down, okay, or cannot identify the problem quickly. So this solution is being running for over 10 years, really played an important role. It's kind of like a standby solution solver for all the engineers. Meantime, it really helped to squeeze 0.5% to 2% per day, okay? I watched a lot of facility engineers, petroleum engineer, process engineers being promoted because they utilize this system, and to help the corporate to achieve the annual profit goal. So this is probably won't spend so many time, just give you the background. Agbami, the FPSO, and there's 32 production wells. They also have the gas injection well, water injection wells. In the peak time, the production rate is 250,000 barrels per day, okay? So we talk about 0.5%, even 0.5% per day, there's a lot of money involved, okay? This is overall the process, and you can see even upstream, they don't have a complicated reaction reactors, okay? But even just a simple process, basically, you know, gathering, this is topside gathering, and then you have the manifold, and then you have the two trains, oil trains, and the water treatment, and there's a overhead compressor, low pressure compressor, then high pressure gas injection, 3 trains. So to optimize this entire process, it is a comprehensive work, okay? So come down to the IOC digital twin integrated architecture, and you can see here, this is the process. This was my responsibility, okay? So we use the USD process dynamic simulation model, the entire topside process, and use the auger model to model the entire production side, because of multi-phase, the 32 wells, well bore, flow line, all the way from the center phase to the topside riser. And we use the Synergy, you know, SPS model to model the single phase behavior, which is gas injection and water injection. And the integrated all together to represent the entire FPSO from a center phase, which is a reservoir interface, well bore, and subsea facility, and all the way to the topside process, and the water line all the way to the deep water dump line, and also gas all the way to the gas back to the reservoir. And we also, this was my vision, based on my vision, and create it. And we also create the reliability index for the critical area. And I will discuss a bit on. And also some ML calculation modulars and provided by the Mitsubishi Heavy Industry, okay, to calculate the index to jointly with the any process information or transit information to build the IOW for support operation. And you can see here, and we also including the petroleum information and the flow line monitoring solutions. FMT means fluid management tool, and the GAP, everyone knows the GAP is the petroleum expert, the wellbore simulators and production network simulators. Okay, and we also use the Chevron Perpetual Optimizer, okay, to optimize, particularly for the downstream, because particularly for the deeper water underground information, because we don't have many sensors, we have to use optimizer to understand what is the parameter range and what the data we should use. Okay, that's what the optimizer is useful. And I'll use the Pi data historian, and we put it in the business land and with the GUIs and the alert. The system is still using, but really don't have a whole lot of the machine learning AI consideration, and all those models are rigorous model. And what I see, this kind of model is not sustainable, and in the current environment, because rigorous model, model is so large, difficult to maintain, and also the license cost right now is so high. From a corporate perspective, to maintain this system is very expensive. You need the people with the special knowledge, and OPEX is so high, with a lot of staff reducing, you know, lean OPEX budget, and all this kind of system is challenged to move forward. Okay, so I can send you the slides. I'm not going to talk about this. Virtual sensor calculation, really, I listed here. So in my mind, the virtual sensor is not just the sensor itself, and is any parameters can be used for the production operation. So number one is a well production grade allocation and verification. They have the well test every week. They have every week production planning. And the system is a platform for the petroleum engineer, reservoir engineer, facility engineer, process engineer. They have the gas injection, water injection, controls, all those functions, and the civil also together to determine next week production plan. Because reservoir engineer worry the reservoir pressure delivered to the sand phase, and the petroleum engineer want to boost the certain well production and go to certain risers, and then come to the top side of the facility engineer say, no, 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 you know, I have the compressor down here, pump down here. I cannot have so many, or maybe I don't have enough capacity. I can squeeze more capacity. So all those discussions without this simulation solution, and we cannot achieve. So, and associated with this, since the solution there and integrated, then you have all the PVT properties, and this is non sparing. Okay, properties, RVP values, water content, control loop settings, and you should be favorite oil more, should favorite the gas more, or should put more flaring, and what is the penalty for the flaring, and all those things has to be considered as a whole, okay, not by silos. And also for the key locations, particularly like the downstream of the choke, each riser choke, and erosion has to be considered. And for the southern part, and then the vibration, especially seawater dump hole, has a lot of vibration, and because it's design issues, and but it come to operation, how you're going to manage it. There's so many things it is being considered. Okay, this is a kind of normal practice they have even today. So any questions so far? Is that I'm talking about too quick or too slow, or any questions? Is okay?
It's good so far.
Okay, case 2, Angola pipeline network, and also the integrated operation center pipeline management system. I designed and developed, but also lead the team with my engineer, work with me. We designed 2. One is they all for Angola LNG plant. Okay, one is cover entire Angola. It's not just for Chevron. Chevron is part of it. ExxonMobil, BP, Total, BP, Sonangol. This is all Chevron. So one is for 3 trunk line. Okay, 3 trunk line, and that goes to, actually this is wrong line. This is actually direct that goes to 3 trunk lines go to the Angola the Solu Angola LNG plant. And then later on, after 2 years, that was 2009 to 2013 we designed. Then we every year we help to improve their system, okay, because they monitor all the gas to the Angola LNG plant. And another one is the for Chevron internal, because Chevron internal has a multiple gas source. Okay, it's complicated by operation scenarios, and we need our own gas monitoring. Okay, to send to the Angola LNG. So objective is the production rate maximization and the safe operation, because gas from various reservoirs, and not always is the lean gas, and sometimes rich gas. So to manage the gas quality, it is critical. Another is because high pressure environment, it is dense space. Okay, they all have IOC. There's 2 IOC location here. One is they're all in the Solu, and the Chevron one later on was here, then moved to the capital in the Luanda. Okay, my team is support both centers. Okay, since I retired, and one of my key staff also retired, and the Chevron lost their capability now. So the supporting role is contract with vendors. That's what I learned recently. The benefit is to ensure the 5 to 10 extra gas production rate added to the network for LNG production. But most important is when LNG has something, they don't want the gas. And how are you going to understand the gas packing, line packing, they call it drafting, and the packing drafting conditions around the pipeline. There's no any instrument only in the source and the location here. So how are you going to understand the leak condition, predicting conditions, and all through those softwares solutions, okay? So first we talk about the Angola LNG subsea network. So the one to monitor all the 3 trunk lines, and is very sophisticated. We have the single phase software and the multi-phase software, and integrate them together. And also, we also have the pipeline corrosion monitoring, use OII software. So this is kind of creative. We all automatically would build a customized link between the auger and the OII, and then tying with the SPS and with SCADA data is the full-blown of the comprehensive the PMS software to make sure the operating point within its own boundary should be top of the limits. Okay, And also some pipeline, they also have the hydrate, kind of goes to the hydrate condition. So we also need to monitor that, okay? So this is the first one. And this will give you the kind of, overview for all the blocks. Okay, this is the old drawings. I don't have the new drawings because my computer returned to the server. I don't have that information. But I think this one is for you to understand. Okay, this is kind of like a pipeline application. The first one is a more deep water production application. Okay, now this is for the Chevron, and you can see, and this is all the gas supply. Okay, that compressor, this compressor is the injection compressor, and actually they take some gas sometimes, not all the time. So in case each platform has own problem, cannot deliver the gas or cannot deliver the gas in the whatever the pressure required, and you need a software, you need a solution to simulate it, it give the guidance, okay, for all those compressor settings. So, and also complicated is there's two lines, this line and this line is a bi-direction. The reason if this one upside down and the gas here is supposed to send to the Angola LNG, and you can't, you have to go back, either go this or go this way for the injection. Okay, and this is the same thing, this. And gas, the delivery rate is different. Some is high rate, like this one has a big rate, this is a big rate. Those are relative small. And how are you going to balance the pressure? You have to run real time to make a decision quick. Okay, so this is for the Chevron. Now another critical is here. It is the pipeline size. This is 20-inch, 22-inch, and come down here the Congo River crossing. And if the rivers here is go deep, 1.5 kilometers. Basically, they drill the hole and connect the 11-inch pipe together. And then in here is 90 degree from 11-inch, then elbow, then just become 22-inch. And then here is 20-inch all the way to the onshore. So in here, you worry about the structure because those are the platform. Congo River crossing is, if the river goes this way, you have a lot of the current, almost 3 meters per second. So they build the platform to handle the connections and all emergency shutdown. So again, for the PMS digital integration architecture, and similar also for the business land, not PCM land. And we build as an advisory tool, really not to control anything, but give the guidance as quick as possible to the operator, to the in the central control room. So from a side, you have the pilot base, and always to the here, and then this is in the Angola. Then go to the Houston cooperation, and really the control, 24/7 monitoring person is in Angola. Okay, we are not a monitor here 24/7, but the system, we manage the system, but the system is in here. Okay, so we do have a USD model, auger model, SPS model with the reliability erosion index and to monitor. All those things is developed later. Initially, is just here, okay? And also we use the optimizer. Now, those optimizer actually is the Chevron Perpetual optimizer, okay? For the SOMG, we just use the auger optimizer and also USD optimizer. So this is a similar application. All this is based on the rigorous model and full-blown, comprehensive, online, real-time solutions. Okay, this is just give you an example of what you look at. If you talk about the virtual sensor, basically all those PMS data is a virtual sensor, and all those is the virtual values, and also velocity is engineering parameter. Erosion velocity is critical. Okay, they monitored. okay? Not want to violate it. And you can see the velocity, erosion velocity, you see, and the way below, which is good. But later on, started from 2022, 2023, we've been not that story, because right now you only have 300 some cubic meter per day, but after 2 years, and most gas were from Chevron side, then this value is going up significantly, and people worry about the structure. Okay, so this just give you, so
Henry, I had a question for you on that one. So does the information you're looking at kind of start at the gathering stations, on those gathering station platforms? Like, you really just, are you looking mostly at the main part coming from the field into the plant, or looking at some of those jacket platforms that don't really have any instrumentation or any power usually?
For this model, and this is the just part of the CIX line. Okay, this is what you see just from here. So really, gas injection here. This is just look at the compressor. Boundary is compressor, not all the way go to the reservoir, because this compressor is suction side. That's what the boundary is. Now this is injection pad. So basically, as I said, but here is shallow water, okay? So they have a lot of instrument, okay? Like Agbami really don't have an instrument. So the calculation is started from discharge of the gas injection, and the model simulated the pressure profile all the way to the deep water.
Gotcha, thanks.
Okay. Now, in here, as I said, the platform have an instrument, but it come down to this is all subsea pipeline, subsea network. You don't have the instrument at all. And even the instrument here is not reliable, okay? And if you use those, including those in the model, and the model will be upset, okay? So we just use for comparison, all right? But in here, we see model calculator, you can see the weight difference, okay, a lot of difference. Okay, those instrument is not tuned properly, okay, so that's a reason. So come down to virtual sensor application, each tag, which tag you're going to pick, really have to do a lot of analysis, and you have to run a model and compare. Now over the time, you know, okay, this sensor is good, I'm going to rely on, this sensor is not good, I'm not going to rely on, I have to use the model values. Okay, so it's just like a human being behavior. There's a lot of behavior you have to learn, then you're used to it. Okay, so now this process, maybe machine learning can help us, but back then we don't have that knowledge. All right, so machine learning for those data analytics, I think there's a lot of usage, a lot of application. So overall, all those value calculated, and the rich and the lean gas mixture monitoring, this is critical, because this is related to the phase diagram. As I said, this phase diagram is shifting, dynamic shifting. Okay, if you have a more rich gas, it will be more higher. And if you don't change this operating settings in the plant, and maybe you come with by the time you receive the gas, maybe the condensate associated with, now over the time you have a hydrate, so you even did not aware of that, all right, for entire pipeline. So that is number one critical, you know, then associated with the land pack, drafting conditions, and all the profiles, gas qualities, contaminant, and the compressor control setting. Sometimes this platform need to be high a little bit, that platform need a low little bit, then you can have the more gas to the one way, the other way, okay? So all this is a dynamic change. So, and what I want to say is this system saved 2 catastrophe potential, avoided 2. And because people go to platform, they didn't wear the gas operation, and one time they closed the valve, and actually in our monitor shows we have that is manual valve. but we build a manual valve, all right? So manual valve is green, but the temperature is the temperature downstream goes down and upstream goes up. Then when we build some kind of logic and we say, oh, maybe you need to look at this. And the coordinator in the control center, they catch up at that moment and call the platform to avoid the potential, the disaster. Another one is in the SPP. Okay, this is just maybe a couple of years ago. This is no man platform, and the maintenance crew go over there somehow. They even today they don't understand how they close the shutdown valve. Those are the 22-inch shutdown valve. There's a big one. I don't know how to close. And there's no signal sent to the either plan or monitor platform and onshore in the Chevron side. But we see the pressure is different. Okay, the pressure is a shift away the normal position. And then that moment, and actually then I believe the Saturday weekend, and I saw that situation. I sent email to the control center look at, then they called the Molango helicopter crew. They fly to there and they try to give the message to the platform. And the platform guys just look at that, oh, helicopter there. Why is helicopter in my head, And they didn't wear that. And after hour, because those are the pipeline, even the temperature shifting, and it really takes some time, maybe surviving time, maybe the 2 hour to 6 hours, something like that. So then the Molango, actually the Solu is sending the boat. It's not far away from here to here, 38 kilometers. Send a boat, and the boat, they climb it, the platform, telling them, you guys shut down the shutdown valve. Then they check it, oh my God, yeah. Because we see all the pressure trend here is rise, and here actually drop down. So those are the two situations, all right? So now I'm going to talk about the onshore application. Okay, so now you know the platform. Do I have enough time? Looks like I don't have the time, huh?
Running a little bit short, but.
Okay, let me go quick. This is the onshore, and similar onshore. We can onshore. There's a lot of wells, and usually the pressure boundary is not that big, not like a deep water or not high pressure pipeline, and very sensitive. So a lot of wells, and each well production not that big. How we manage it? We also build this. This is for Nigeria, the DD field, and have a site information, goes to a local information, then go to Houston. Actually, this is the both place is in the Lekki and the Houston, and then we integrated all the information together, and mainly is auger based, and then do the pressure management, okay? And now, in the practice, we have the operator go over there, go each well hourly to write down the information sent to the Lekki, and then people type in, petroleum engineer type in. And if we have I believe someone already developed this, maybe the Hitachi Vantara, some kind of robotics, because a lot of well is a manual gauge, okay? So if you have a scanning tool, can get to monitor those gauge and the conversion the data to the database, and I will say is very useful. And I'm looking for those kind of technology, and I believe those technology will help existing onshore wells or any gauge operations significantly. I call it robotics. You can call it anything, okay? As a kind of device, can scanning those kind of tools. All right. So this is the one kind of application. I can send you the slides. Now this is more interesting. The corrosion online monitoring. I'm not sure, Chris, when you work for the Chevron, you're aware of that. This is a smart facility project, and then we did it for the Richmond refinery. Okay. I go a little bit quick. Is Unison full blown of the refinery process simulation, but we're adding the software calculations in the feed stream based on the lab testing, and use the Kami curve. Basically, this is a kind of corrosion curve provided by the corrosion engineer, and put it in the model and tie into the Pi database, and to calculate the this is the kind of architecture to calculate it. This is a process to calculate all those corrosion rate. Okay. Why we do that? Because we put it online for the testing for a while. This is probably maybe five years ago. Okay, and today they stopped. Okay, why? Because if you remember, Richmond has a big catastrophe accident in here, because one of the pump actually corroded and caused the fire. Okay, and one of the crew trains stopped for 2 years, and associated with a lawsuit from the Richmond cities. So that's the reason we developed this kind of a solution to prove the concept, and basically we can monitor the corrosion rate as long as your the corrosion calculation is correct. But this is all, as again, you can see, based on the rigorous model, very complicated, and dragged to run real-time environment, it is a challenge. Now, if we have the machine learning correlation to simplify the process, that would be really nice. The last one is the deepwater fixed equipment integrated production integrated operating window development. And that is still ongoing. That is, I'm still doing the consulting for Mitsubishi Heavy Industry. That's how we initiated 5 years ago, learn from the field needs, okay? Really, we identify the deepwater production and see all those behavior can be indexed or not. And we develop the methodology, become indexed. And it is under deepwater, DeepStar consortium umbrella, and doing the research, but funded by Nippon Foundation, okay? And this is still ongoing. We completed the erosion for subsea choke, topside choke, and now they are doing the FIV, and then next stage, we're going to do the more for VIV and also the single phase, the gas line, okay? This is architecture. So one side, you have all the process solutions, okay? Provide the process information, especially the flow rate, the velocity, and those informations, and the phase informations. And you have the robotics, they develop robotics, as I said, isolated application for the wall thickness measurement, okay? For the elbow, for the subsea, for the topside choke elbow, and it goes to the database. And then we follow this process, coordinated with industrial standards, and do the RAM analysis, and do the CFD, a lot of CFD calculations to try to cover all the operation range scenarios, and then create the correlation, utilize the machine learning analytics methods, create the database. The database then create the common kind of mathematics algorithm can be coded, then becomes reliability index, and initially embedded in the process model, okay? Now is become independent software, and then sent to the database. So they can shake a hand between the process side, reliability side, through the database. So all these things, those areas, there's a lot of area is related to the virtual sensor, and also related to the machine learning, okay, thinking. But right now we're just beginning, okay. As I said, our workforce regarding the new technology, not good as you guys. That's the reason we should keep the dialogue and to help the industrial to adopt the new technology quicker and improve the application. So this is give you example, this is the topside choke, you have the sand, then you have a, rotting situation here because of high flow, big pressure drop. And with these solutions, then you can predicting the index, likelihood of failure index over the time. And also you can see the regime in above this line, or is not that good. And then you also see the boundary and identify the integrity operating window associated with the production information and rep information, try to expand it, and in the past, people always think about this is my safe zone, or maybe this is my safe zone. Really, for the production, we want to push to the boundary. That's reason more and more we more rely on the IOW, okay? So then we can squeeze out our, give them more production profit. This is something, another results, and I do not want to extend it here because of time constraint. So now I would like to talk about the moving forward the plan, my views. I think of the 21st century, really all those solutions should be end to end. But current practice really is a function silo. Even what I'm doing, try to extend it to the other side of the fence. But still, I would say probably in the past, I practiced more and more leading this area within the Chevron and also our peers. But still, since I retired, I looked back, still is silo. Because current tech knowledge is difficult to do it because we're all based on the rigorous modeling. So we really need new thinking, new way to model, utilize the machine learning methods, okay? Another thing is the operator should use the leading edge. That's what I say, the digital twin technology, but we really don't have good practice in this area. One is the cost, another people knowledge, and the way adopt the new technology is relatively slow, okay? And integrated solution, it is the way to do, and really a lot of hidden values we can identify and analyze through those solutions. This should be the way to do. And the data collecting, data creating, it is also important. And I believe the rigorous simulation and the machine learning, AI, they can work together. One of the challenges is that people always say, oh, I want to do the more simulation, real time, machine learning, but I don't have the sensor, I don't have the data. But the rigorous can create a lot of those information to support, let the machine learning methods get better, okay, over the time. And the robotics is really important because you can reach to the area you want information without interfere with the PCN network. Okay, I will show you the next slides. And also another thing is that right now people in the design area, in the construction area, and operation area, they don't talk to each other. Okay, for the digital transformation, and I don't see any design area and design the plan. Think about operation side can be digital transfer. Okay, so that's another area. So this is the key I presented here and challenge you to thinking. So currently, in high level, people working the PCN network, the plan's already there, it works, okay? But a lot of information not have in the lower level, okay? That's what we designed, okay? Once you have the control system, advanced control, DMZ, and they have a lot of data. And people working here more in IT, basically fundamentally two layers, is the plan operation management and the business management. And this area, IT play important role. There's a very complicated layers, they integrate together. So basically you have a IT person, control operation, okay? They come down here, more maintenance, and how are we going to let them work together? So I think the way is digital twin. So we need to build a digital twin to mimic the entire this chain, the entire this level, and utilize and the IIoT infrastructure on newly the edge computer cloud or whatever, unique to mimic the entire facility from here to here. And the people here, they don't want IT interfere with them because it really comes down to control, all right? And also you have a cybersecurity consideration, is way complicated. But most time we want information is not here because over the last 20 years, all the DCS information is already there. In the last 5 years, particularly, we build a lot of database in this layer, and then they can get data, whatever the data existing here, they can put to here. But a lot of information we really needed is in this level, and we don't have it. Then we need to use a virtual sensor, robotics technology, or machine learning, whatever the information, and to drag it without this vertical integration. We show the vertical integration in this layer. Okay, so overall, this is my message. And that's what I'm thinking every day after retire. I'm thinking how we do it. And what I lie down here is basically mimic this level, you know. So message is we should not just improve those two networks. We really should build this network independently within intranet, within security, protection, and not send information back to here. Back to here, give them as reference, but we should take the more information from here. Okay, and build the level as from 0 to 0.4. Mimic is not just physical facility, but should mimic as the plan control level also. That is my message. Those are the areas we need to working on. Once we have this, then we can have autonomous operation. Okay, so overall, we should support the autonomous operation. Pretty much that's my message. This is my core message. Any questions? I know there's a lot of time, you know, that's what I said, a lot of information here. And I already try to speed up.